Assalamualaikum and hi. We chose to make a smart traffic light as our title for this project. And these are my group members. And in this video, we explain in details on how we made this project a success.
First, set up the Raspberry Pi with micro SD card and connect it to the internet. Then, build the circuit on the breadboard which connect the LED at the GPIO 2 until 4, 17, 22 and 27 for the ultrasonic sensor at the GPIO 23, 24, 25 and 8. After that, we open the Tony software. Open the new Python file and write the code. The last process is run and test the program.
Hey, hi, my name is Muhammad bin BAKAR and I will be explaining this smart traffic light demonstration. Before we start, I want to note that the ultrasonic sensor should be set up parallel to the lanes, not perpendicular, so it can detect cars within 50 meters of each lane. For this demo, static car means continuous traffic. Okay, so let's proceed on response number 1, normal traffic sequence. So for the setup, 2 cars are on each lane. This will trigger the normal traffic light sequence because both lanes have cars waiting. So green light for 30 seconds, yellow light for 1 second, and then red light for both lanes for 2 seconds to neutralize both lanes, and then it will repeat. Next, we will proceed on the response number 2, where one car is in waiting while the other lane is empty. As long as the other lane is empty and the sensor detects that there is an incoming car on the current lane, the light will stay green. Once the car, as you can see, has gone over and the ultrasonic sensor doesn't detect anymore, it will end the extended green light time. Okay, now for the third response, it is similar for the second response, but with opposite lane. So when the other lane is empty, the current lane will keep on turn green, and then once it goes over, it will immediately end the sequence. Now let's see what happens if there's car on the opposite lane during the green overtime. Green overtime means the green light is extended because the other lane is empty. So if a car approaches on the opposite lane during green overtime, the current lane's green light will end instantly and the other lane's green light sequence will start. Okay, now I'll demonstrate the same situation but for the opposite lane. The sequence will be the same. Once the car approaches on the other lane, it will end the current lane's green light and start the sequence for the other lane.
In this project, we are using Raspberry Pi to control a traffic light system with 2 lanes. So the system uses ultrasonic sensor to detect the presence of vehicle in each lane and adjust the traffic light accordingly. First, we have RPI GPIO, which is a module to control the GPIO pins of the Raspberry Pi, and we have time module that allows us to manage time-related tasks. Then we have GPIO set warning, which function is to disable warning about GPIO pins being already in use. This part is used to define the GPIO pins for the LEDs, and we have this part which is to define GPIO pins for the ultrasonic sensor. Then we have setup GPIO, set mode GPIO BCM, which set the pin numbering mode to BCM. Then we have LED pin setup, which we configure the LED pins as output pins, and we have ultrasonic sensor pin setup, which configure the trigger pin as output pin and echo pin as input pins for the ultrasonic sensor. Next, we have a function to control the LED output by changing the command GPIO output to turn on pin command. Then we have function to turn on LED to red. Next, we have a function distance which sends a pulse from trigger pin and measure the time it takes for the pulse to return to the echo pin. And finally, it calculates the distance based on the time difference. Next, we have normal traffic light sequence, which will be activated when both lanes have a presence of car. Then we have traffic light sequence function, which manage the traffic light based on the presence of vehicle detected by the sensor. So this function keeps the traffic light lane as green light on as long as no car is detected in the opposite lane. And finally, we have the main loop function, which continuously check the distance from the ultrasonic sensor from each lane, and depending on the distance reading, it runs the normal sequence or adjust the sequence based on detected vehicle.
I will be explaining about the frequently asked question for this project. And for the first question is, how does the ultrasonic sensor detect vehicles? So the answer is, sends out a sound wave. So basically, the ultrasonic sensor that we have been used sends out a sound wave through the trigger pin and listens for the echo on the echo pin. The time it takes for the echo to return is used to calculate the distance to an object. If a vehicle is within a certain distance, as our program mentioned, which is our distance is equals to 20 cm, so the vehicle will be detected. And the next question is, why are the traffic lights always turning red after a sequence? The turn on red function ensures that both lanes are set to red after a traffic light sequence to reset the system and prepare it for the next detection cycle. This acts as a safety measure to ensure no vehicles are moving when switching control between lanes. And the third question is, how can I adjust the sensitivity of vehicle detection? The sensitivity can be adjusted by changing the distance threshold in the traffic light sequence and main loop functions. For example, modifying the if distance strip 1 echo 1 is lesser than 20, which is 20 is our distance. It allows you to change the 20 cm threshold to a different value. The fourth question is, what happens if both lanes detect vehicles at the same time? The system processes each lane sequentially based on the order of checks in the main loop. If both lanes detect vehicles, the lane that is checked first, which is the lane 1, will be processed first, followed by lane 2. After processing both, the system resets to red light for both lanes. And the last question is, how can I extend this project to control more lanes or add more sensors? To extend the project, we can add additional sets of LEDs and sensors for more lanes, and we would need to define new GPIO pins for each additional lane and modify the logic in the traffic light sequence function and the main loop to handle the extra lanes. Ensure we configure the new pins correctly and add appropriate conditions for detecting vehicles in the new lanes. And for this last question, it brings us to the modification part. This part, we can add or put another features to this smart traffic light system by adding another lanes or else. So what we need to do is, first of all, we need to define a new GPIO pins for the LEDs and ultrasonic sensor for the new lane. These pins are used to control the LEDs, which are red, yellow and green, and read signals from the ultrasonic sensor. The next part is, we need to configure these new GPIO pins as either outputs or inputs echo pin of the ultrasonic sensor. So the third part is, modify the function to ensure all lanes, including the new one, have their red lights turned on. Next, extend this function to handle the new lane by adding a new condition. For example, like we adding an extra lane. So in the program, we write it as lane equals to 3 to represent as a new lane. And lastly, we extend the main loop to check for vehicle detection in a new lane and call traffic light sequence function for that new lane when a vehicle is detected. And that's all from us. Thank you very much for your time.